Hi, I'm David with Portrait Displays, and we're coming to you from Los Angeles, California in a reference review room where we're going to show you how to calibrate the Sony BVM-HX310 reference monitor. This is one of the main monitors used throughout the Hollywood production and post-production communities for mastering content. Let's get started. Down here you have all of your settings for the Sony BVM-HX310. On the bottom we have power, menu, back, and our select enter button. This is going to be the main tools you're going to use to access the system. Let's press menu. To start, we come up with the status page. This is a great way of quickly selecting and cycling through the different aspects of the monitor. It's especially great for ascertaining how the monitor is currently configured in case you have any questions. For example, we see we have a BVM-HX310, we're on version 1.10. As we come down to the next page, we're currently sending in single link 12G SDI, 3840 by 2160 at 2398, coming in 444 RGB 10-bit. This page is really great for ascertaining what is coming to the monitor if you have any questions or concerns about your signal path and what is making it to the display. Additionally, you'll notice that we're in the limited mode, so we're narrow range. User presets 1, color temps 1, BT709 with an EOTF of 2.4. From this menu, I can determine that we're currently in a BT709 2.4 narrow range format, so most likely I'm going to be mastering HD content. As we come back from the menu, we come back over here to user preset setting. You'll notice we have our user preset 1, user color temp 1, again the same stuff we were just looking at in the status menu, but now we're able to adjust it. So if we want to adjust this, we could go to 2, 3, 4, etc. Now, the way this works is user preset 1 is the memory, and everything below this is assigned to user preset 1. So if I made a change here in user preset 1 where I change the contrast to, let's say, 410 or 411, and I come back, now I go up to user preset 2, you'll notice it's back at 400 because it's tied to the user preset that it's in. It's a very modular system, meaning I can mix and match things across between memories, inputs, etc. So we'll put that contrast back at 400 where it is defaulted at, and we'll come back up here. Now, if we hit back and we come down one more menu from user preset setting down to color temp, you'll notice we're in color temp user 1. Well, why are we in color temp user 1? Well, we're in color temp user 1 because this is in user 1 and user preset. Now, if I change this to 2, we come back, we'll notice that this is now changed to 2. And again, that's because the memory that we're in, the input setting that we're in, which we'll get to in a moment, is in user 1, user preset 1. And so whatever that's in is then going to select whatever the color temp is, and that's going to come down into the color temp setting. Once we're in the color temp setting, we have a couple options here. One is to adjust it. The other is to choose your signal. You can choose an external signal or an internal signal. If you're using an internal signal, you wouldn't be using an external test pattern generator. This is really great if you want to do a quick check on how the monitor is calibrated. Once you go into the gain or bias, you'll notice that a pattern has now come up on the screen. That pattern has come up on the screen because we've set it to internal. If I come back and we go to external and we hit adjust gain bias, you'll notice that when we bring this up, we're actually seeing the external pattern generator that we're sending into the display. This is excellent if you want to do an EOTF sweep to check the EOTF response as well as the white balance tracking, to track the saturation sweeps to see how the color gamut is mapping, or maybe even a color checker. Any type of measurement you're trying to do from an external source, you're going to want to keep the signal set to external. Let's go back. If we come down one more in the menu tree here, we'll see user configuration 1 of 2. There's 2 pages here. We're going to skip over to the input setting. That's going to be the most important thing when we're calibrating the display. Let's hit input setting. Now what you'll notice is we have SDI1, SDI2, and HDMI. Under SDI1, we have SDI1 4K and SDI 2K. What this is telling us is we have an SDI1 4K memory and an SDI1 2K memory. Why is that important? On most displays that we calibrate today and we work with today, we don't have a separate calibration setting between, let's say, 1920 by 1080 content and 3840 by 2160 content. We usually have one calibration, and that applies to both. So with the Sony here, what they're giving us is the ability to say, hey, when I'm sending 1920 by 1080 content, I want the display configured to X. And when I'm sending 3840 by 2160 content, I want the display configured to Y. That way, a user can actually change the calibration of the display just by sending it different content. For example, I could have 1920 by 1080 content set to BT709, but I could have 3840 by 2160 content set to HDR P3 ST2084 full range. So then all I have to do is set up my system as an operator for the project I'm doing, and the Sony will automatically change. Now, if you're an advanced user, this is your monitor, you work in the same room, it's your room, that might be an excellent way to work, to be very hands-off with the monitor. My recommendation though would not be to do this if the room's being shared, you have multiple operators, people are coming and going. And the reason for that is someone has to know how you had it set up. And if they don't know exactly how you've had it set up, they're not going to be able to ascertain exactly what's going on. And they're going to call engineering because they're going to say, hey, I've changed my resolution and the monitor changed and I have no idea why this looks so different now. Let's get a little bit more into it, and we'll kind of go through some recommended best practices. Let's come back down to the user configuration, input setting. Let's click on the first one, SDI1 4K. In fact, let's actually go down to where I am. I'm on SDI2. So let's go into SDI2, I'm on 4K. So I have input setting 1. Just as I went over the user configuration before, we have the user preset 1 and then the color temp and everything below it, we now have input setting 1. Think of input setting as the highest level. It goes input setting, and then what you'll do is you'll actually assign down here a user preset to the input setting. So when you select the input setting, it will choose a user preset, which then chooses your color temp and chooses everything else. And you can mix and match these things quite a bit. If we come back up, we'll notice what we have here is we can say input setting 1 is going to go to input 1. We're sending 12G SDI in, so we're on input 1 and we're sending that 12 gig signal. Here we have single link 12G coming in. VPID auto is set to off. I personally don't like using VPID auto just because I don't know if everything's going to have the metadata that will automatically achieve my goals. I really like in post-production environments or production environments to have everything very specific, very manual. I want to know that when I put a monitor into a specific mode, I'm getting exactly what I wanted to. And anything that's auto isn't necessarily going to let me achieve that. Again, if you test the system and you test the practice and you know that your system and your hardware and your equipment is doing exactly what you want, there's nothing wrong with this. It just comes down to how confident you are with the equipment you're using. For colorists and operators that move around a lot to different facilities, it's hard to know exactly what's going on in that facility. So having this very deliberate selection helps instill confidence in the process. Let's come back in as we timed out to input setting. We'll come back down to input setting 2, SDI2. All right, so range. Similar to any range in any system, we have our limited or narrow range, our SDI full range, and our full range, and then we come back around to limited. And you'll notice you can actually set the range separate on RGB or YCC or YCBCR content. So if you're in YCC, you could have the monitor go to a different setting. If I put this to full, right now, if I just change what I'm sending to the monitor instead of RGB to YCC, we're going to find that the monitor automatically switches into full range. And vice versa, if I'm in YCC and I switch over to RGB, right now it's going to switch back into limited or narrow range. So it's very important to understand how this is set up, and that status page can help you in the beginning, or you can really dig into the menus, because it's very easy to have something not line up with what you think it's going to line up for. Color space, this is where you're going to select your color space target. Right now we're in BT709. We have EBU, SIMP-DC, native, S-Gamut, S-Gamut 3, S-Gamut 3 Cine, DCI-P3, ITU-R BT2020, and then back to BT709. Transfer matrix is going to be the conversion matrix from YCC to RGB. I recommend running RGB all the time if you can in a post-production environment. You go through less conversions. If you can't run RGB and you have to run YCC, make sure your transfer matrix is set up properly. So BT2020 for BT2020 content, BT709 for 709 content. If you're running P3D65, which is a mode used in post-production, a format used in post-production, set this to BT709. There is no matrix for P3D65. As such, most of the applications we see today are actually using the BT709 matrix instead of the BT2020 for that P3D65 content. So that'll get you a little more accuracy if you have been using the BT2020. If we come down, we have our EOTF, or our response curve. Now, what's great about this on the Sony, a lot of people have asked me, how do you set it up for HDR? Well, you set it up for HDR. And what I mean by that is you have to target something that's high dynamic range. So if we come down here, right now our EOTF is targeting 2.4. That's not an HDR EOTF. If we come over to, we have 2.6 CRT, notice that once we got over to 2.4 HDR, we're now in an HDR EOTF. S-Log3 HDR, S-Log2 HDR, ST2084 HDR, or PQ, BT2100 HLG, S-Log3 Live HDR. It's specifying if something's specific for HDR. As we come back around 2.2, 2.4, you'll notice the monitor came back down in its brightness. And the reason it did that is because it's trying to track what that format is. So it's putting it into the highlight output mode for HDR content, and it's putting it into the non-highlight output mode, or the regular output mode, standard output mode, if you will, for SDR content. Come down to the second page here. We've got image division. That's going to apply to our quad, our dual. How do we want this image to be ascertained? Now, auto might work well. You might find that 2SI needs to be selected, square, or back to auto. So going through that is important because I've actually seen on a lot of studios where certain output cards don't flag the auto very well with the Sony, or I should say they don't play nicely compatibility-wise with the Sony. So being able to set that and force that lets you understand what you're looking at without having to, again, trust the auto. Signal format, auto, YCBCR 10-bit, 444 RGB 10-bit, YCBCR 10. But what's really great about this setting is if you're not sure what you're sending, or let's say you're running through a lot of projects, or again, you have multiple operators in a room and you're not sure how a system's being set up, if you force this and your picture looks wrong, it's very good checks and balances for knowing what you're getting. For example, let's say that you want to be working in 444 RGB 12-bit and you set this to 444 YCBCR 12-bit. Well, now if you come in and you're sending RGB, it's going to look incorrect. And if it looks correct, you'll know you're not getting RGB. It's just a really good way to ensure you're always getting what you want to be getting. You should still always check and not rely solely on this, but we have seen a number of studios force this into a very specific mode so that they know what they're getting all the time because the picture looks accurate. It's just another way for them to say, if this doesn't look right, check your settings, you probably have something wrong. We're gonna leave this in auto for now. User preset. This is where we're saying our user preset. So if I tell input setting 1, which is what we're in here, to use user preset 2, I've just changed the calibration. What I've changed is, as we come back here, we'll now come back up here and we'll see we're now in user preset 2 with color temp 2. And if I change my input setting to keep it in 1, but change the user preset back in the input setting to 1, we'll now notice that we've come back to 1 here. So again, input setting, user preset. Within the user preset, you have your color temp. So it's very important to make sure that this cascades properly for your workflow. And it's where most people using these type of monitors get confused because it's so robust and so powerful, and you can really configure it a million different ways that it's easy to lose track. So what we like to do when we calibrate these displays for customers, we meaning when I was a calibrator, but Portrait is we're teaching here, I like to set these up the same. Meaning whether you're on SDI1, SDI2, or HDMI, I like to set them up so all my input settings are the same. That way I can tell an operator, input setting 1, whether you're using SDI1, SDI2, or HDMI, is let's say BT709. If you're using input setting 3, whether you're using 1, 2, or HDMI, is going to be P3D65 HDR, let's say full range. That way, if someone comes in, starts changing wires, plugs in another source, changes some output because they want to work in quad versus dual or single or 12G, they don't have to think about how that was configured. They can just go to each one and choose that input setting and know that it's calibrated no matter what they're using. And that seems to work the best for everyone I've personally been involved with. So if we were to do that, and this monitor's already been configured, what you would do is you'd go into input setting, you choose 1, and you say, okay, I'm going to set input setting 1, let's say for 709 legal. So you'll come down, you'll make sure RGB is limited, you'll make sure YCC is limited, so no matter what they're sending in, it's going to be limited range. BT709 color space, transfer matrix BT709, because we're saying 709, so if we are in YCC, we are getting the BT709 matrix that matches our target, EOTF 2.4, and then user preset 1. Now, a very common mode for post-production, especially working in the Dolby Vision format, is to have BT709 in full range. Not common if you're only working in BT709 HDR because it is a narrow range, limited range format. But if you're working in HDR and you're working in a full range workflow, it isn't uncommon to look at the BT709 in full range to do your trim pass and to be working at the same time simultaneously between the HDR and the SDR. So what we do for a lot of our customers, we set this up to 2. And as we come down, you'll notice we're in full BT709, BT709 2.4, and we have user preset 1. If we come back around, input setting 2, go to input setting 3, we'll notice full DCI P3 for the P3 color space, BT709 transfer matrix 2.6. So this is set up right now. What we're seeing here is this is actually set up for DCI P3. DCI P3 meaning a 48 nit P3 color gamut with a DCI white point 2.6 EOTF full range. That's what we're seeing here, and what we're seeing is that has been set up to user preset 2. If we come back to input setting 1, we'll notice we're in user preset 1, limited range. If we come back to input setting 2, we're in full range and we're still in user preset 1. Why? Because limited range and full range don't change the calibration on the Sony BVM-HX310. While some monitors may need a separate calibration depending on the range, the Sony BVM-HX310 allows you to calibrate it and switch ranges without the need to recalibrate. Let's come back up. So we've got what we've said is input setting 1 set to 709 in limited range, narrow range. Input setting 2 set to 709 in full range, again for that trim pass if you're working in the Dolby Vision workflow and you have HDR as well as SDR being optimized at the same time, graded at the same time. If we come to input setting 3, we've got DCI P3. Now DCI P3 is a cinema format, and I do recommend that if you're grading content for cinema, you do it on a projector, you do it in a cinema, because that's where it's going to be exhibited, that's where it's going to be viewed. But of course, if you want to set up a mode on your Sony, you're able to do that, you're able to work with it. Just take note that I would always recommend doing a final trim pass on the actual format that's going to be exhibited on TV. It's going to be exhibited on TV, such as the Sony BVM-HX310, the monitor behind me. Cinema content's going to be exhibited on a cinema screen. It's going to be hard to get the same experience on the smaller monitor. Let's press menu, come back into our input setting here. And now let's go over to input setting 4. So 4, as we selected 4, we'll notice this just got a lot brighter. It just went into the HDR mode. That's a telltale sign. So we've got full range, P3, transfer matrix 709, ST2084, user preset 3. So now we've got 3 user presets. We had user preset 1 with 709, user preset 2 for DCI P3, now user preset 3 for HDR P3. And I bet you if we come back around to input setting 5, we're going to see that this is full range BT2020, ST2084. We'll notice that the transfer matrix is also BT2020, and we are in user preset 3. Again, because the Sony is going to convert color spaces, what we find is that if you calibrate, say, 100 nits of luminance for 709, that P3, that 2020 at 100 nits is all going to be converted very, very well, very, very closely. If you're in HDR mode, closer to that 1000 nits, you'll find that you'll want to use a separate calibration because the higher light output does change some of the color characteristics of the display. We find that with almost every display. It's sort of like running a car at 2,000 RPMs versus 8,000 RPMs. The characteristics are a little bit different, right? We're pushing this a little bit harder. As this heats up, the color temp's going to get a little bit different. So we can really fine tune it by using these separate settings. So here we are using user preset 3, and it looks like, again, we have 5 settings based on what we've seen here. And we've got them BT709 Limited, BT709 full, DCI P3, P3 D65 PQ for HDR full, and BT2020 PQ HDR full. You don't have to work in full range. You don't have to calibrate these for full range. It is a very common, very popular workflow in post-production for people to work like this, for artists to work like this. There are studios and customers that I've had in my past life as a calibrator that will work in limited or narrow range for HDR content. And there are others that work in the full range format. It really comes down to your workflow, how your system's set up, how you're working, how you're delivering, and how you want to achieve your goals. Now, there's another thing that's very important with the Sony monitor is how do you choose your input setting? We've gone through the input settings themselves, but what you'll notice on the bottom here, if we come to the bottom, we actually have input setting skip. Input setting skip allows you to use the input setting buttons down here, SDI1 4K, SDI1 2K, SDI2, both 2K and 4K, to toggle through the memories that we've discussed. So if we were to come to SDI2 and we toggle this, you'll notice that we're in input setting 2. I press it again, we go to input setting 3. Press again, we're in input setting 4. Press again, we're in input setting 5. And if we come back around to input setting 1. How that is set up is by going to your user configuration, input setting, down to the input we're on, and coming down to the input setting skip. Now, when we don't skip, when it's set to not skip, we're able to toggle through these by pressing that input setting as we just did. But if I set these to skip, as you see here, it's not going to select those. It'll just choose the input itself. So if I choose all of these to skip, it's now just going to go to SDI2 when I select SDI2. How would you choose your mode? Well, another trick here is to either set it in the input setting, or you can come back to the function button setting. The function button setting allows you to set these 7 function button keys on the bottom to be a quick button. F1, F2, F3, F4, F5 are set for input setting 1, 2, 3, 4, and 5. I personally really like this method. I like the idea of being able to select my input, skipping everything and just going straight to the input, and then choosing, after I select my input, exactly what I want. This allows the user to be very confident in what they're selecting versus having to cycle through. The Sony monitor doesn't allow you to name input settings. You're unable to know exactly what you're choosing when you cycle through here. So right now we're in P3, PQ, full range on input setting 4. If I come here, we're now in BT2020 PQ full range, but it doesn't tell me that. So if I know it because it's my monitor or I'm the operator of this on an exclusive basis, I might feel confident cycling through. But if you don't feel confident, it's very easy to make a little cheat sheet. F1 equals this, F2 equals that, F3 equals this, and then just putting that cheat sheet there for the operators that are coming through the room. And that way they can just select their input, select their standard, and get right to work. I really like that method of approach. These other settings you might see below don't really pertain to the calibration we're going to do today. So what I'd like to do now is I'd like to get the equipment set up, and we'll start to go through a calibration to fine-tune the Sony BVM-HX310. All right, as you can see, I have the Colorimetry Research CR300 spectroradiometer, the Colorimetry Research CR100 colorimeter, the Sony BVM-HX310, and we have a machine running Calman. So let's get into calibrating the Sony BVM-HX310. While Calman launches, it's important to note that while I'm using the Colorimetry Research meters here today, Calman supports a large variety of spectroradiometers and colorimeters, including the Portrait Displays C6 that I have here. Let's get started. With Calman loaded, we're going to want to start our calibration process. Now, since I'm using the Colorimetry Research CR300 and the CR100, what I'd like to do is I'd like to calibrate the CR100 using the CR300 by building a profile within Calman. So let's start by going to Calman, Open Workflow Template, Tools, Meter Profiling. This is going to launch the meter profiling workflow to help us walk through the meter profiling process. I'm going to take the Sony, press Menu, come down to Input Setting, choose the input setting I'm on, and I'm going to change the color space from BT709 to native. Now, why do I want to do that? Well, I want to do that because when I'm profiling my meter, I'm measuring red, green, blue, and white. and I want to get the most neutral red, green, and blue for my meter profile for the highest level of accuracy. If I'm correcting the monitor to BT709 and the monitor has a wider color gamut than BT709, green may have red and blue added to it. The meter doesn't understand that red and blue has been added to green, and it doesn't calculate that out. So it's always best practice to put your monitor into a native mode when building a meter profile for the best results. Now that we've got our monitor in the native mode and we've got our meter profiling workflow loaded, let's hit Profile Meters. Our first step is going to be connecting to our hardware. Let's press Find Meter, choose a COM port. We'll start with COM port 4, hit Search. We've now connected to the CR300, but we also want to connect to the CR100. So we'll hit Find Meter again, choose COM port 7, hit Search. Now we've got our CR100. Next, we'll want to connect to our pattern source. Today, I'm using the Virtual Forge pattern generator loaded on the Windows machine running Calman with an AJA IO 4K Plus output card. This allows me to send SDI12G in RGB format directly to the monitor. Here, I'll press Find Source. We're going to choose SpectraCal. Let's come down to SpectraCal Virtual Forge. You'll notice it was found on the network here. We'll click on that and press Connect. We've now connected to the Virtual Forge and the pattern has changed to the grayscale you see on the screen. Let's press Next. The next step in the meter profiling workflow is to take reference meter data. This is going to be used later to correlate to our profiled meter to see how accurate the profile came out. Let's choose our reference meter by selecting the Meters tab. Choose the CR300, come down to the bottom right and press Read Series. At this point, Calman's going to put up a patch, take a reading, and plot the data. It's going to go through white, red, green, and blue. Okay, now that our reference meter data has been collected, let's press Next. The next step here is to create our meter profile. To do so, we're going to use the pane on the right side here where it says Create Profile and set up our meter profiling session. The reference meter being the Colorimetry Research CR300, let's check the advanced options. I currently have the CR300 set to slow. I like using slow when building meter profiles or doing work that's super color critical. The reason for this is it's going to take a longer exposure, but it's going to get me a higher level of repeatability and accuracy from the CR300. If you happen to use the CR300 to perform a calibration, you might want to change it to normal or even fast. Just know that the faster you run the CR300, the less repeatability and reliability you may have from it. Our next target meter is going to be the CR100. So we're going to change this to the CR100. And let's just take a look at our advanced options. Notice I have the exposure multiplier here set to user mode. This is a little trick when using the CR meter. If you use the CR meter app, the CRI app, to set the meter exposure on the meter itself, you're able to use the user mode inside Calman to leverage that. Instead of Calman taking 5 exposures, the meter can take 1 reading with 5 exposures on board, speeding up the process. Since I have my CR100 set to 5 exposures here for today, we're going to leave this in the user mode. As we come down, we're using the source as the SpectraCal Virtual Forge, and we don't need it to prompt us for pattern changes because it's going to automatically change with Calman. Our next step is to create the profile here on the bottom. So we're going to hit Add Profile. It says Untitled 8. I'm going to rename this. I'm going to call this the BVM-HX310-CR300 because I'm building this with the CR300. Now, I'm going to use a single pass. Calman allows you to do a single pass or a multi-pass. And the reason I'm going to use a single pass is because both my CR300 and my CR100 are on the screen at the same time, so they can take the same measurement, saving me some time from having to swap out meters with a multi-pass. Okay, now that our meter profile has completed, let's press Next. At this point, we're going to do a profile validation by measuring the display with the profiled meter to then compare it to those readings we started with at the start of the workflow. We'll hit Read Series. Okay, now that the series is completed, let's press Next. On this last page of the workflow, we're able to compare the reference meter to the profiled meter and see how close they actually got. So let's choose white to start. We'll choose white on both sides, on the reference and the profiled. And now what we're looking at is the data from each meter. X was at 0.3124 and 0.3123, a difference of 0.0001, an excellent result. On the Y, 0.3287, 0.3283, again, a difference of 0.0004. Excellent result. And the candelas per meter squared, or nits, are measuring 99.51 versus 99.38. Again, right on target between the two. Let's take a look at red. And we'll kind of go a little quicker through this, and we'll just take a look to see if anything stands out. X matching perfectly, Y matching perfectly, and our luminance is still within a 0.1 nit between the two. We'll go to green, green. Again, X measuring perfectly, Y measuring 0.0001, and our luminance a little further off, 67.81 versus 68.27, but still within a very tight tolerance. Blue, X matching, Y matching, and our luminance within a 0.03 tolerance. Excellent. So now that we have our CR300 and our CR100 profiled together so that we're getting the accurate results from the CR100, let's go up to our Calman menu, scroll down to Open Workflow Template, choose Analysis, and let's go to the SDR Toolkit. I'm going to say don't save from this workflow. You might have noticed we've also disconnected from our pattern generator through that workflow. One of the reasons Calman disconnects from the pattern generator during the meter profiling workflow is so that it's easier to select and look at the data without having to load a pattern, especially if you have a pattern delay loaded into Calman. It's going to take that much time as you change each pattern because it's going to want to change the pattern as well. So let's go up to Source and choose the source and then choose back to the SpectraCal Virtual Forge. It's already connected, it's already loaded. Our next step here in the process is going to be choosing our calibration targets. Remember, I changed this to the native color space for building the meter profiles. So now I want to go into Menu, scroll down to User Configuration, choose Input Setting, scroll down to the input setting I'm on, which is SDI2 4K. Let's come over to Color Space and change that back to ITU BT709. Now we're back in 709. We've got Limited, 709, 2.4. Let's back out of the menu. Let's come back to Calman, choose Options under SDR Analysis, and let's set up our calibration targets. So we have Video or Narrow Range, Limited Range, Color Space, Rec 709, sRGB, White Point at D65, and the gamma formula is at BT8TA6. Let's change that over to Power 2.4. So let's change it to Power. And on the right-hand column here, let's change 2.2 to 2.4. You'll also notice there's hardware down here. The display type is referring to the colorimetry research and the meter profile built into the colorimetry research itself. We're not using a built-in profile, so we're going to leave this in factory. And we're going to use the Calman profile, as you see here, BVM-HX310-CR300. Our pattern size, window 10%, pretty standard for calibrating one of these monitors. Let's go back to the welcome screen. At this point, the Sony BVM-HX310 is primarily calibrated using a 2-point grayscale. So I'm going to go to the grayscale 2-point to start. I'm going to choose white to start with the white, and I'm just going to hit Read Continuous. Calman's going to put up a pattern, take a continuous reading. On the left side here, we can see on the RGB balance how our red, green, and blue is balanced against our target. And on the right side, we can see our delta E. Now this monitor has already been calibrated, but let's mess around with this a little bit to walk through the process. With Menu, I'm going to come down to Color Temp, hit Select, select on the gain and bias, and now we can adjust the red. And if we're looking at the Calman window, as I change red from 1114, as I come down, we'll see the red coming down on the RGB balance chart. And so we're red deficient now. We don't have enough red in our signal. Now I can also, when adjusting this, I can also change the green now to come down to the red. And as I bring green down to hit our calibration target on the balance chart here, you'll notice blue is now a little high. So if I go to my blue and I bring blue down, I'm now balancing them off. They're now about even. Now the problem with what I just did is I brought red, green, and blue down. By bringing all three down, I've effectively reduced the luminance of the Sony BVM-HX310. So while my delta E here is extremely low, and while my RGB balance chart looks excellent, I'm going to press stop. I'm going to go over to the grayscale multipoint because I want to see how my luminance is. BT709 in a reference environment is set to 100 nits. So I'm going to come up here, choose 940, which is my peak white in my Calman layout today. And I'm going to hit read. Okay, so I pressed read, And now in the bottom left-hand corner here, you'll see under current reading, we've got X at 3126, Y at 3284, and our candelas per meter squared, or nits, is at 94.96. So we're actually a little low. What I've done here is by reducing the red and then following it with the green and following it with the blue, we've brought that luminance down from about 100 nits where this was calibrated down to 94 nits, 95 nits. So to bring this back up, the Sony has the red, the green, and the blue. But if I want to adjust all of this as one to effectively bring the luminance level back up on the display, I can adjust the contrast control for RGB. So I'll choose the contrast control, and as I start to turn it, you'll notice all three of these are now increasing. If we want to come back to Calman, we can hit our read continuous, and it's going to read continuous as I make my adjustment, and I increase the luminance until we see candelas per meter squared come up to our target. So here we are at 99, 99.9, 99.6. All right, here we are at 100, 100.4, 100.2. So we're hitting that 100. A very important thing to note with the Sony BVM-HX310, once you're done making your adjustment, make sure you press the select enter button to save. You press it, it'll exit you out, and then you can hit menu or back to get out of the menu. If you don't press select enter and you press the back button, it's going to reset the controls to when you went into the menu. So if you do find yourself getting into trouble and needing to reset the display, just back right out without hitting that select enter button. At this point, we're measuring 100 nits, 0.3127, 0.3286. Perfection would be 3290. Our delta E2000 is 0.3. Let's just take a sweep here. We're going to put black up. We've been sitting on the white for a little bit. Wait a couple seconds, and then let's hit the read series. The read series is going to put up a pattern, take a reading, and run through the entire range so we can see our EOTF or gamma response, as well as how grayscale tracking is happening throughout the entire range. Okay, so as you can see, we've swept the grayscale, and we're tracking the EOTF curve excellent. The RGB balance is very good. And we've got an average delta E2000 of 0.2, an average gamma of 2.4, and we're hitting 100 nits, 3126, 3287 at the top end. If we want, we can change this chart to ITP and look at how our delta ITP is doing. Currently, our average ITP is about 0.33, and you'll notice on the chart above, nothing seems to be at or over a delta ITP of 1. This is an excellent calibration across the board with the Sony here. Let's take a look at how our color gamut is tracking, because even though we have the grayscale and EOTF now tracking D65 and hitting the EOTF that we wish to have, we still want to make sure that we're hitting the color gamut mapping where we expect it to be so that we're not working in a color space we didn't intend to work in. So we're going to hit read series here on the color gamut page. Okay, so we've now measured the color gamut. In delta E2000, we're at that 100 nits again for white, and it looks like our delta E2000 is under 1. We're hitting our target points. If we go to delta ITP, we'll notice we are coming up a little bit closer to 2 on red. If we look at red, we can click down here on the bottom on the Calman pattern selector, and we'll notice red is not quite hitting its target, which is what's causing this error here. But we are mapping as we would expect on the edge of the gamut. And one of the things to note here is that we are in a brightly lit studio environment, and the lights that are coming on me are also coming on the display. And that light can also cause some washing out of the display. And the meters, they don't understand that there's this light and the display light, they're just measuring light. So this could be a factor of a little bit of that ambient light coming into the meter's path and causing a slight shift, but still a very excellent result for the monitor. Let's go up to the color checker, jump right to the color checker, and let's see how the inner part of the gamut is mapping, because just because we have the outer part of the gamut mapping properly doesn't mean the colors inside the gamut are being mapped as we would expect. So let's do one more test here on the color checker, and then we'll move forward with the HDR portion of the calibration. Okay, as we can see, the color checker is finished, and you'll notice on the CIE chart here that just about everything's hitting its target very nicely. We are still in the delta ITP formula, and if we take a look over here, average delta ITP is 0.64 with a max delta EITP of 1.99. Again, it's that red that seems to be pushing. It's these edge parts of the gamut. If we are to take a look at those, we can choose red down here from our color checker. And you'll notice over here that we're just not quite hitting that that target. Same thing if we go to blue or 100% blue, well, we're just not quite hitting it perfectly. But again, excellent, excellent results. And typically SDR is measured in delta E2000. If we look at delta E2000, we are at that max delta E of 0.63 with an average delta E of 0.21. Again, excellent results. So we now have the monitor set up and configured for BT709 2.4 limited range, and the grayscale has been adjusted to D65 within that gain menu on the color temperature. Now let's set up and let's move over to HDR. So I'm going to take my my monitor, and because I know that F4 on this monitor is going to take me into P3 D65 full range for ST2084PQ HDR, I'm going to set this over here to input setting 4. You'll notice the blue has gotten brighter. Let's now come back to Calman. We'll hit Calman, come over to Open Workflow Template, Analysis, HDR Toolkit. Let's not save this workflow. We're going to load the HDR Toolkit, and we're going to go through a very similar process on the HDR side of things. Our first step here on the HDR Analysis Toolkit is going to be to choose Options, and we'll choose our standard target. So right now, since I'm in P3 D65, a very common post-production workflow, not something you'd use at home, I'm going to change the color space from Rec 2020 over to DCI P3. Okay, DCI P3 loaded. White Point Custom 3127-3290 D65. We're in the ST2084 HDR PQ EOTF curve, and the delta E charts are currently set to ITP, which is commonly used for high dynamic range. There is one more thing though. I'm going to come up to the gear icon here in the top right corner and change my range, since I'm in full range on the monitor, to PC levels, full range within Calman. And now while Calman's calculating that, it's changing the Calman test patterns and how Calman's working, but it's not changing my AJA and how my Virtual Forge is generating patterns. So I'm going to come down to my task menu down here, the Windows pinned menu, launch the AJA control panel. I'm going to change my format from SMPTE to full. I'm going to change my SDI output from SMPTE to full. And I'll close this. And you might notice there was a change on the monitor as I made those changes. So now Calman, the generator, and the monitor are all in full range. Should all be operating in that standard range there, and we can come back to our welcome screen. Just as we had with SDR, we're going to use the gain and bias controls to calibrate the grayscale. So we're going to come over to the grayscale tracking, select it, and I'm just going to pick 1023 full range 10-bit here and press read. Slide over on the data just so I can see that, but you'll also see this here on the current reading on the bottom left-hand side. You'll notice we're at 3126, 3287, foot Lambert's 271, candels per meter squared, or nits, at 928. So we're actually tracking D65 very well here, but again, if we want to, we can start messing with this. So we'll hit read continuous. Calman's going to take continuous reads. I'm going to show you how to adjust this. Menu, come down to our color temp, and you'll notice we're now in user 3 because that input setting that we changed before is using user preset 3, and user 3 is assigned to that. So we're now not adjusting the user 1 that we were adjusting for SDR, but we're now in user 3, which is a completely separate adjustment. We'll click adjust gain and bias. And once again, let's say I want to take the green from 1075 and I start bringing this down. If we look at our command screen, we'll notice in the RGB balance window, green is coming down. And as I bring red down now to match the green, I'm once again bringing down my luminance as I do this because I'm reducing everything to get them to match. And I'm using these RGB balance windows just because it's easier to see from where I'm located. But if you want, you can use the XY data. So if you do look at the XY data here in the bottom left, you'll notice I'm at X3081, Y3215. So I'm leaning too far to the blue on the CIE diagram. If you're thinking about a CIE diagram, I'm going down to the left, I'm leaning too far blue. If I take that blue out now, I'm going to start taking that blue out. It's going to start moving towards that 3127, 3290. Now I'm looking at the X and Y, 3124, 3125, 3126. And notice I'm at just about 3126, 329. So I'm at 26329. I have dropped down to 923 nits, but let's hit select enter to save this. Let's hit menu out. I'm going to hit stop on the continuous read inside Calman. I'm going to bring up black. I'm just going to wait a few seconds here on black and then take a sweep. And the reason for that is we are pushing the monitor pretty hard with that peak white in HDR. It is going to heat up the panel. You might get a little bit of instability on any panel that you measure when you're pushing it that hard for that long. Real content doesn't sit at that light level for very long on a monitor, so it's not going to have the same effect on the panel when you're watching real life content, but we do want to make sure the panel stays in a more normal operative state. So let's hit the read series now. As we can see, we still have down here under 1023, we have 312, 329 at 922 nits. So we're a little lower than a 1,000 nit target that we like to hit with these monitors. Keep in mind that the age of the monitor, the use of the monitor will all affect this. If you have a monitor such as the Sony BVM-HX310 with a lot of hours on it, especially in dynamic range mode, the wear and tear is going to start to bring down that luminance. Doesn't mean it's going to not calibrate well. It just means that you might not be able to hit that peak luminance like you're able to. We've certainly seen some of these hit 1,000 plus nits, and we've seen some of them hit 960, 980, even a little lower depending on their age and their use. Now, one of the things that's very important when calibrating an HDR display, we don't really want to target the peak luminance and the white point as our primary. And what I mean by that is we want to make sure the EOTF, the tracking, the SMPTE ST24 PQ, perceptual quantizer tracking, is actually tracking the curve very well, because HDR is what we call a bit per nit. A certain bit level is supposed to equal a certain light level. It's very much specific in how it works that way versus a relative method such as gamma tracking in SDR, where 2.4 is more of a relative curve than it is an absolute curve. If you're looking at my charts right now on Calman, and we look at the RGB balance with luminance, we're going to notice that this chart is starting to track low as it comes up to the clip point and then hits the clip. It's hitting the clip because PQ goes all the way up to 10,000 nits, and this monitor is not a 10,000 nit monitor. So at some point, it's going to have to hit a clip point because it's not going to be able to go all the way up to the maximum range of 10,000 nits. But what we're seeing here is we're seeing this luminance reduction coming down on the PQ curve. And if we look at the target curve, we can see the gray line tracking just underneath the target line. What that means is that we're too low on our luminance. So while we're getting this 922 nits and while we're hitting 3127, 3290, we're not really tracking PQ as accurately as we can. So what I'm going to do here, and there's a lot of ways to approach this. You could adjust the luminance and then resweep, adjust the luminance and resweep. We're going to choose 512 here in the middle. We're going to hit read continuous. And what I'm going to do now is come back over to the monitor. I'm going to hit menu, come over to color temp, and we're going to adjust this RGB contrast, bringing the luminance up equally until this chart shows us that we're hitting about our target line there in the middle. So what we're doing is we're turning up the luminance on the monitor to get the EOTF curve to track appropriately. Keep in mind that HDR content, while it can go up to 1,000 nits, 4,000 nits, 10,000 nits, the majority of content is at that 200 nits and lower level. So the most important content is really going to be in that 0 to 200 nits. The monitor needs to be as accurate as it can be in that 0 to 200 nits, because that's going to cover over 90% of the pixels that are on the screen when you're watching HDR content. As you go up, those percentages come down. The amount that's over 200 nits is a lower percentage. Over 400 nits is a lower percentage. The amount of content that's actually at 1,000 nits or 4,000 nits is going to be less than 1% of the pixels on screen during any movie. So we don't really want to target that very small amount of the pixels that we're seeing. So I'm going to adjust this and bring up that EOTF curve to try and track PQ better. Okay, so now we've got this about right at that middle point there, 512 if you look at the chart. I'm going to press select enter, exit out with the menu button, press stop on my continuous read. Once again, go back to black just for a moment. And now let's hit read series and see how we've affected the EOTF curve and the tracking throughout the range. Okay, so if we're looking at the chart now, you'll notice that we're tracking around that 100 target line much better. We get up to that 700, around that 1,000 nit. We hit the hard clip, and we continue up. We have seen a little shift in our grayscale balance. If we're looking at delta ITP, our delta ITP without luminance is still very much at 0.9 and under, and our delta ITP with luminance hits that higher number of 2.6 at the clip. And what's happening is it's hitting a hard clip on the broadcast monitor. So a broadcast monitor is typically going to track PQ as perfectly as it can until it can't and then stop. It's up to the artist that's mastering the content to put that data into the mastering process so that when we get the content at home, our displays know that this content was mastered at X level of nits, and then the display can tone map that into the display's capability that the viewer is watching it on. But for post-production, we do want a hard clip, and we are seeing that hard clip as we come up this curve, and we go into that hard clip. Now, we could probably tweak this a little bit more, maybe pulling out a little bit of red and blue. Let's do that real quick to see if we can get this just a tad bit better. Looks like 3118, 3286, and we're tracking 915 nits. So we've lost a little bit. I'll hit continuous read on the white real quick. I'm just going to make a slight adjustment. This might get us just a little bit better. And you can really drive yourself a bit crazy making these adjustments if you want to chase it. But these results we have here are very, very good. But it does start to become the law of diminishing returns. You might spend 20, 30, 40 minutes and you get a half a delta or a quarter of a delta better across the board. We'll press select enter there as we've adjusted the red and blue slightly. Let's stop. This monitor has a little bit of age on it. It is hitting a slightly lower nit level than we'd like to see. But again, the more important thing is that we're tracking PQ, we're tracking it where it counts, and the artist is going to know that they're hitting about 915 nits, 920 nits. They can put that into their mastering process, and that can get all the way to the consumer where the consumer can see the content just as the artist intended. As this is measuring, we talked about tracking the PQ curve. This is one of the things where calibrators start to get a little off with these monitors. If you're using the internal test pattern generator on the Sony, you're only able to measure white or gray. You're not able to set the luminance to make sure you're tracking that EOTF curve. This is where Calman is really indispensable because you're able to track an entire EOTF curve, see where it's tracking, make sure you're hitting that bit for nit as I mentioned before, and make sure that you're really tracking that standard as accurately as you can. If you were just using the internal test pattern generator, you'll be able to white balance, you might be able to target a luminance level, but you're not going to be able to validate that EOTF curve and make sure that you're right where you need to be. And as you can see, when I brought that luminance down to about 920, we were tracking low on the EOTF and getting slightly larger numbers. Okay, here we are again. We're getting a current reading of 3126, 3295, 903 nits. So we are a little lower in our nits. We are tracking PQ pretty well. Our deltas are very low. And as I said, if you'd like to spend a little more time with your monitor, tweak it a little better, you certainly can. There are also other workflow layouts that might be more beneficial or work a little better in your workflow that you might want to look at. Changing the scaling on the charts, if you were to right click and hit properties in Calman Ultimate, you're able to change the scaling on the charts and maybe get a little more granularity. I'm going to change the chart to minimum 97. We'll change this to a maximum 103. And we can now see a little more granularity into what's happening here with the RGB balance and work from there. But let's now jump forward and let's take a look at our color checker. This will be an excellent way for us to see how is our color gamut mapping occurring now in this P3 D65 full range PQ mode. We know we have a good white point at D65, and we know we have our EOTF tracking very well against the PQ curve, but let's make sure our color gamut's where it needs to be. While we're measuring the color checker, let's take a moment to discuss alternative white points when calibrating the Sony BVM-HX310, the history of which comes from legacy calibration methods. In the past, we used CIE 1931 as the model for our color matching function, as well as D65 as the white point. This is the standard that we still use today. But when CRTs were king, this is what was used on CRT after CRT, and they matched very well. Once RGB OLEDs were introduced into the market, they had a very different spectral power distribution, which led to metameric failure when looking at D65 calibrated using the 1931 color matching function. To combat this, Sony found that using the Judd modified color matching function and calibrating to D65 made an RGB OLED look similar to a CRT. This became sort of a standard practice, even though it wasn't a standard that we were all using to calibrate RGB OLEDs. As other technologies, such as the dual cell modulating layer LCD in the Sony BVM-HX310 came to market, we also noted slight shifts in those technologies, leading to the suggestion of alternative white points. The problem with using alternative white point is it only matches the monitor you're trying to match it to, and it isn't the standard. For that reason, studios took a step back. They were using the RGB recommended OLED white point offset based on the Judd modified color matching function for RGB OLEDs, but once other technologies started to hit the market, they said, no, this is getting really complicated. It's going to be very hard to track the alternative white point from display to display, from vendor to vendor, from production company to production company throughout the entire community. While we're using the Sony here today, it's important to note there's many broadcast monitor manufacturers on the market that are very prevalent throughout the community. For that reason, the studios have settled on using 65 with a color matching function of 1931 as per the standard, moving forward with most technologies. Now, that doesn't mean that every monitor is going to be calibrated the same way. But what we do is we calibrate the hero monitor, such as the Sony BVM-HX310, to the 1931 color matching function, as we've done here today, at D65, and then we'll calibrate the client monitor or the review monitor, the secondary monitor, such as the monitor you see behind me here, to D65 CMF 1931, and then create an alternative white point to perceptually match the Sony and the LG. And what we're doing is we're not adjusting the Sony because that's our hero, that's our reference monitor. We're adjusting the monitor that's behind me to match the Sony. So this might end up with an alternative white point, but that alternative white point isn't really a standard. It isn't something we're targeting over and over again because it is to combat the metameric failure between the display that's behind me and the Sony BVM-HX310. But then there's one more thing that comes into play, the observer. Observers don't all see everything exactly the same. That's what we call observer metamerism. So we have the display metamerism, where the spectral characteristics between display A and display B may not match, but then we also have the observer metamerism, where it might not match between me and, say, our camera person behind here. As such, we tend to calibrate the hero monitor to D65 CMF 1931, as I was describing. Then we calibrate the other monitor using the observer who's going to be operating in the room and matching it perceptually for them, because they want to know that their client, who might be sitting in front of them watching the client monitor, is seeing the same thing they're seeing when they're looking at the reference monitor. And it's all about the artist's perspective and to their eyes. So we've calibrated this to D65, which is standard practice. It is being used throughout the Hollywood post-production community and the production community at D65 pretty much across the board. Maybe a couple outliers, but pretty much across the board. And that's a little bit about using alternative white points. Let's take a look at our color checker analysis. As we can see, our gamut mapping is hitting the target here on the right side of the CIE, and our delta ITP with luminance error is a max 0.75 with an average of 0.47, and our without luminance error is a 0.76 and a 0.41. Very interesting that that came out that way. Let's take a look at delta E2000, and again, very low, max 0.5, average 0.15. This is tracking as we would expect post-calibration for the target that we're targeting. Now you can apply this method to the BT2020, to DCI P3 at 48 nits, and you can work through this process to set up your input settings, your white points, adjust them, and make sure your ranges and everything is configured for your operator. I hope you enjoyed this video. We'll see you in the next one.